Thank you very much. So yeah, as I said, yeah, thanks a lot for coming, and thank you very much as well to the organisers of this conference as well. I'm yeah, very excited for the weekend ahead. As we say, my talk is why and how all your Python code should be declarative, or as declarative as possible, in the age of generative AI, or at least generative AI hype. So before I go on, I should probably introduce myself. My name's Weldon, like we say. I'm broadly speaking a software engineer, although it's never quite good enough to just be sort of one thing, is it? You can get an idea of some of the technologies that I use generally from some of the icons that you can see up there, and so that's all very well and good. I'm a software engineer, and I used to call myself a full stack software engineer. I think that's a little bit more punchy these days, obviously, kind of worth being. And now, obviously, the last couple of years, I've gone down a much more fashionable route of being a platform engineer, which is where I find myself today. I'm based generally in central London. You can get a flavour of it from there. But I am actually a Manchester boy originally. I grew up here, and so it's actually really quite fun to be in the centre of Manchester, a place I had lots of memories of from sober teenage evenings, back in the day. I primarily work as a contractor in financial services, and I've been working for one place for quite a while now, mostly in sort of engineering internal frameworks, in particular with kind of quantitative research around markets and so on, and the platforms that enable that to be possible. I decided not to name them here, not for any mysterious reason other than I'm not on work time and not here in an official capacity. I'm just a guy having fun in Manchester talking about Python. I do, though, use another technology, and that is because I have an academic background in computational geography. So I try to think what's the best way to symbolise that, and unfortunately, even very postgraduate levels, that's still probably the best symbol that we have here. So that's going to be relevant towards the end of this talk, and I'll explain why that is, and sort of a little realisation that I've had there. So, moving on to the actual talk and sort of thinking about what we'll be covering. We'll be looking at what really is Python under the hood very briefly. We'll look at ways that you have of coding in a declarative fashion in Python, using in particular the annotations system, as well as some interesting changes that are happening in 3.14 that comes out next month, sorry, on the first Tuesday in October, as per. And then we'll look at a couple of lessons from geography, at least, in terms of how to manage code being declarative, certainly in the age of generative AI. So it's probably worth thinking about what do we mean by this term declarative. Well, really, there's lots of kind of formal computing definitions that you can use, but in the broadest possible terms, we are describing what you want your code to do, not simply or just how to do it. And we use this in relation, when comparing things to an imperative program, where you're saying do this, do this, do this, rather than defining the actual kind of computation that you want to be performed, and then ensuring that that computation gets done. So you might think, actually, I've got loads of information about what I want my code to do. I've got my documentation, for example, that says what it should be doing. It's a dirty word to bring up Jira of a Friday afternoon, but we've got plenty of tickets that say all of this should have done, and the pull requests and stuff like that. But actually, when I'm talking about declarative code, what I mean is recording what you want to be done, what your computation actually is, inside of the code itself. And so, let's think about this at a higher level. And just before we do that, let's dive into what Python really is and what Python's all about. And so if we go to Wikipedia and say, let's take the first sentence of the Wikipedia article about Python, we find out that it is a high-level, general-purpose programming language. And so if we think about what does that mean, general purpose? Well, you can do just about anything in Python. The problem is often that people do. And you can do anything from sort of, a little bit of data analysis right the way up to writing a web server or a compiler or something like that. And we're not confined to a particular domain like we might be in a domain-specific language. This is also a very high-level language, and what we mean by high level. Well, first off, we're not coding on machines that look like this anymore. we have very high level sort of human-friendly sort of syntax and things that we're coding on. And just as a monkey union, I wanted to take a very quick little detour here to look specifically at this image. Does anyone recognise it? No? Okay. It's the Manchester Baby. It was the first electronic stored program computer built, just about has that title. It had 1,000 bits or so, 1024 bits of memory, 7 processor instructions, and it was built literally within half a mile, I think, of this place. And this here is the mock-up, or the kind of, this is the replica that you can see in the Museum of Science and Industry, which is just about a mile up Oxford Road that way. So do definitely check it out if you get time. It's in the Revolution Manchester Gallery. And we're getting really local to Manchester now, but the South Manchester suburb where I grew up, Rumley, this was the guy that, one of the 3 guys that built it, alongside a lot of other people. So as a Rumley lad, I thought I'd have to reference Frederick C. Williams there. So good old Fred. Right, but no, getting back to Python. I would say this is a very high level language. We write instructions in a kind of human form, we're not just writing processor instructions. And so that means that we have to have this thing here, which is a language. And what is a language? Well, it's really a kind of an agreed convention that's used by a particular community. What community is that? Well, it's us. There's a whole community to Python in the form of PEPs. There's the Python Software Foundation, and there's all of us in this room here when we're attending PyCon. So this is very much our language, and what connects this language that we have to those processor instructions? Well, we have the implementations of Python. Normally when we mention Python, we're talking about CPython, but there is also IronPython, there's Jathan. I realised just before I came on stage here that I've missed out MicroPython, so sorry guys. But there are other implementations too. And so that's the executable here that sort of takes our human instructions and then turns them into processor instructions. And so actually really Python is already a pretty declarative language in a sense. We're writing code that's interpreted to produce this bytecode, and then that ends up as a instruction on your machine in the form of processor instructions. And so this is actually a really good thing. Like if we understand Python this way, it's a way of declaring what we want a computer to do. And it's not just like a programming language where we're just like writing commands. We're actually able to use a really rich grammar here to say, hey, this is what I want my computer to do, and also crucially why. And we can declare that business logic alongside our code, and that's a really, really powerful and useful thing, and we should do it more. And this used to be a controversial opinion, at least until Python 3.10, 3.11, but I would argue that it's actually a really good thing, and here's why. So first off, let's look at a little feature of the syntax here, these Python annotations, they're called. This surprises most people when I say it, but Python annotations are almost 20 years old. They were introduced as a part of the grammar in 3.0 in December 2006, PEP 3107, and it defined this kind of standardized way of annotating parameters and return values. And it was actually a bit of a punt, really, in a sense. It's like, oh, we're not going to put any formal semantics in here about how to do it. We're just going to let you do it and then see what happens. The idea is that we want people to innovate and encourage experimentation here. And so the rationale was that actually loads of people are already doing this. You might remember sort of the kind of various different types of doc strings that you got to use years and years ago. And then still actually about the different kind of formats and stuff, and that's what people were trying to have some kind of standardization to record what their code was doing. And so the rationale was people are already doing it, let's let them do it as part of the grammar. And so nowadays you most commonly see type annotations really is the formal use of these annotations, and so you're probably familiar with that down there. You're able to put some type annotations onto a function. And then we can access those type annotations using this kind of dunder annotations attribute here. These exist on all functions. They exist in modules as well. So you've got this kind of silent dunder annotations. Most of the time, exactly how it depends on the version of Python and a few other things, but you've got it there. And you get them on classes as well, and we can access what's kind of been put in them there. So this is the most common sort of style of annotations that you'll see here. And so that's all very well and good. But actually, it doesn't have to be a type that you use in an annotation. It's really literally any Python expression can become an annotation. So anything that evaluates to something in Python, so basically not an assignment, for example, can be a type, or can be an annotation. So actually you get some pretty surprising code towards the end of it, like this. You might have seen this before. I mean, like, yeah, you can put a dictionary as an annotation. Don't. But you can write a function here where you start to get very confused, but obviously, that int or float is perfectly valid Python, because the or operator just returns the first truthy value it finds, or false. So a type, yeah, that's truthy. So we've got that. Same here, yeah. We get the annotation. We get the return value for it as well, and we can even call the function and it works. But yeah, don't do that either. The worst one, I did have it. I was doing this on a train, thinking, what's the most kind of fun one that I could come up with the other day? I think I've settled on this. I'm sure there are probably better ones that you can do. Yeah, I mean, that's perfectly valid Python that compiles and it doesn't compiles, interprets. Yeah, you get that, and get a nice little fried snake. So yeah, cool. Never do this unless you really hate your colleague or something, or you just really want to annoy people. It's a bad idea, obviously. But the point is that actually any expression we can put as a relevant annotation in our Python code, and it's legit in the language. It's not a problem. No, this is a feature, not a bug. The primary use case, though, in recent years has become type hinting, and basically PEP 484 sort of solidified that years ago. There are a couple of quirks as well, it has to be said, about the way that you access this this annotations attribute. So basically don't do that. And the primary way that you should really be accessing this information generally, is normally through this typing.get type hints that exists in the typing module. If we look at this here, this is how we kind of get this information. But actually, the typing system shouldn't have a monopoly on these annotations. It was put in there as a source of innovation in the language. And there was a PEP that came along, and I think this was introduced in between 3.9 and 3.10. Essentially type hinting at this point had become the de facto use for most annotations. And essentially it was crowding out anyone, or any other use that you might want to have for this information inside of your Python. And really, we don't want typing to have that monopoly. And so this thing came along, this typing.annotated. And this is what we call a special form. It's a bit of a mysterious thing, really, in the language, but it's basically just a special object that we have to say, hey, actually, yes, I know that normally this is a type, and yes, I do want that type information. But I actually also want another bit of information that I can put alongside it too, please. And so, we essentially have to pass at least one type. We have to pass one type as the first thing that we put to this special form, and then everything else after that, have as much fun as you want. It's great. The typing system, when we, for example, call get type hints, it will recognize that, oh, hey, yeah, this is the type, but there's some other information here, and that's not relevant to me, so I'll just let it go. And if we actually do want to get this information, there's now a separate tool available to us that was introduced in Python 3.10 called get annotations in the inspect library here. So we've got these kind of two separate systems now. There's annotations, and then there's types. Types kind of use the annotation system, but because they're the superstars of it, most of the time we say this is type hinting and so on. And it's worth just referencing what happened in 3.10. So initially type annotations were a bit contentious, and then that was kind of a contentious period in Python generally. There are some criticisms that you can put in it, quite legitimately. They slow down module loading a little bit. I mean, if you were to, suddenly compute 10,000 factorial in a type annotation, then that would slow things down. Again, don't. There's the other issues here as well with forward referencing, and it can cause some headaches. So, for example, if you've got a book that's got a list of chapters to it, that's going to throw a name error because it's not defined yet. And so, historically, until Python 3.14, you would have to use string literals there to reference objects that exist later on in code. Yeah, and I've messed up the animations on that slide, so sorry. So yeah, to solve this kind of problem, well, to kind of solve these sort of headaches and address this kind of issue, like what are we going to do with what are we going to do with these annotations? There was initially a PEP that was called Postponed Evaluation of Annotations, PEP 563. And the idea here was that, hey, all of this, this annotation stuff, it's gone far enough. Let's just treat it as a string and then get back to computing things, please. And so the idea would be basically any annotation, as long as it's valid syntax, just becomes a string literal, and you can go and process it to your heart's content. And this was initially accepted into Python 3.10, and then it was placed into the future I forget what we call that particular module or something, but placed into the future, so it's not going to be turned on by default. You can enable it, and we can see here that I've put a particularly silly type annotation in for a bit of fun. But here, if I was to now get my annotations using that function, I can see it's a string. It's not actually kind of separate sort of bits of information, or it's not parsed. The reason why this was put into the feature and it wasn't sort of allowed is that essentially this would have broken loads of really useful modern tools that exist inside of the Python language. So Pydantic, Fast API, all that kind of stuff. It relies on these things being evaluated at runtime, and trying to write the logic to evaluate them in Python code that's also running at runtime, just it wasn't going to work. So another PEP came along, and it's also worth saying actually that when it was put into the feature, rather than it being that there's some kind of parsing being done of, rather than that these attributes are sort of being stored as strings and just being parsed when they're asked and needed, and it's actually the opposite. They're parsed as part of the language, and then if you want it as a string using this feature method, then it's made into a string using AST. But anyway. So along came another PEP, this 649, and the idea was for deferred evaluation of annotations using the descriptor pattern. And so it's a whole topic for another day, and I'm sure there'll be lots of talk about descriptors in various other places. But the good thing to know is that this is coming in Python 3.14. And essentially what this means is that annotations are only going to be evaluated when they're accessed, which does speed up a little bit about how kind of Python works in that sense there. And so if we kind of take an example here, the one thing that you might notice straight away is that the place where or the kind of point in your code where you get certain errors will vary between Python sort of 3.10 through 3.13, where this zero division error that I put in there intentionally, and that would get raised when we're actually kind of parsing that code initially. Python 3.14 though, the error gets raised a little bit later on. It's only when we ask to inspect that object and get its annotation that the error there is raised and say, hey, you can't divide by zero. That's spooky. And so we see that it's only the error is only there when it's raised. And also you all might notice that this annotation lib exists now, and it's brand new in the standard library, and it means that you don't have to import everything from inspect to be able to look at annotations. You can kind of use them here. And so these annotations have some metadata to them, and we can access that metadata and look at how that's done here. The metadata is meant to be used by frameworks. It's a good thing to do and a good thing to use. The only thing is that, like I say, other people, other frameworks can use this information too. And so the reason why it's available to us as this kind of tuple of metadata objects is so that if you come across something that doesn't look like anything that you're concerned with, just ignore it. That's the rule there, really. You can put as much metadata as you like, or an object can have as much metadata as it likes on it, but only pay attention to the stuff that you're interested in. Now I'm going to use a slightly convoluted example very quickly about why you should use annotations. So let's imagine I've started a wallpapering firm, and obviously I'm great at wallpapering, totally. I'm not going to mess up your living room, promise. I need a script to work out how much wallpaper I'm actually going to use. And so I can start off, write something really, really simple and straightforward like this. Obviously that's not going to be very good. I forgot that you can have more than one wall. I live in London, it's a very small flat, you have 4 walls, God no. And so then I come along and think, okay, right, I'm going to refactor my script slightly, have more walls now. oh, actually business is going a bit better, I'm going to record some information as a config file, I'm going to have this API that exists as an external service tell me how much extra wallpaper I need to buy as a safety factor and stuff. Business is taking off, great, I'm going to plug this into my online quotation form and stuff. And this is all getting very complicated now, and what was a simple script is, there's already things that we should refactor out and do. And if you multiply this kind of, oh, I've done a quick script for something, and then, I've got lots of people in a big organization, comes along, oh, you've got to do this quickly. I promise you that everyone who works in code professionally has some script that they can think of right now inside their organization or inside their project that is they're afraid to touch because this kind of stuff has happened. And the reason why it does happen here is because we're putting a lot of the kind of the immediate logic of like, oh, I need to open this file and I need to get this information right next to the computation. If we look here, really, the only thing that's about wallpapering here is this, multiplication, multiplying these three numbers together. That's the only thing that you really need to do, or four numbers. And so the important thing to do, I would argue, is identify the code that we care about, which, in this case is really just this very simple, multiplication, and then to, start doing the rest and all of this plumbing as declaratively as you possibly can. So in this case here, I'm going to, I've made these little metadata objects that I'm going to be looking for, just called ref and the params and outputs and stuff. I've labeled where these should be coming from. And then this, I realize, is a lot of code to look at in a small space of time. But basically what I'm doing here is inspecting this object. I'm going to call the function that I've got here, look for all of these particular annotations, only pay attention to the ones that are relevant to me. And then that'll decide how I call my function. And it's annoyingly, I haven't put it in here, but trust me, this works. and this will call your function for you. And you can just say, right, these parameters are what what's going to be available to me at runtime. And I could be getting them from a database, I could be getting them from an API, I could be getting them from anywhere. So some of the more eagle-eyed amongst you might think, yes, this is dependency injection. It always is. And this is a good thing. This is the most declarative possible way that you can write code for the most part. You identify what needs to be sourced, where from, and by how, what means, and then you're able to put it through there. Now, just very quickly, I'm going to say this is a very convoluted example. I'm not really wallpapering at the weekends, promise. But it comes down to a really important point. Being a developer isn't just about writing programs. It's about much more than that. And I'm going to very quickly lean on my geography background here, and a realization that I had very early on in the course of my kind of postgrad adventures in geography. And it's just what the word means itself. It's like geography, earth writing. As soon as you kind of realize just quite how simple that is, it's like, oh, actually, yeah, this is what geography is all about. I mean, I'm originally waging war, but I mean, well, the post-colonial turn of geography would mean. Geographers spend time exploring the relationship between humans and their environment, and their people, places, structures, processes. And then crucially, they write it all down. That's the important thing. And we present this knowledge in a way that's easy to share with the world. And that's actually really important because being a programmer, Python gives us a lot of ways to record what our code is doing and why it's doing it. And what we need to do when we're coding is often discovering the information about real-world processes, and that's really, really hard. This bit, the writing the code to implement it, should be really easy. It's just plumbing a lot of the time, but it often isn't because we're actually mixing up these concerns. And when we start to realize that actually Python gives us a really, really good way of recording all of this in a structured way, of writing it down, and that these are really powerful tools, and we should look to use them as much as we possibly can. Finally, just when I originally sort of wrote the spec for this talk, you've got to think about what the fundamental way of delivering some kind of value that you want to work with is. You find out what needs to be done, you do it, you get the value. But I'm now very, very skeptical of the AI sort of idea here, and that comes down to the idea that, hey, we still get that value, just got to have the right prompts and record things in the right way, yeah? Magic brain will sort it, boom. And I think that's vastly oversimplifying most problems, to be honest. And the kind of the reflection that I kind of come to on this now is, especially reading Tim Berners-Lee's memoirs that have come out a week or two ago, And the most important thing is knowing what computers are good at and humans are bad at, and vice versa. What humans are really good at and what computers are actually, probably able to take a lot of stuff away from us with automation. And that's the doing it. These things will always change. There'll always be new patterns and technologies and things that we can use, and that's great, good. But this bit's hard. This is the human bit, and this is what being a developer is all about. And in particular, writing it down, and Python gives us a really good syntactic way of doing that. So yeah, just in summary, and I'm sorry there's not maybe time for questions. Actually, it's the first time I've delivered this talk, so feedback is very, very welcome, and I'll have to slim it down in future. But Python's a very high-level language, lots of useful specs for combining metadata and logic. Annotations, good thing, use them more. Declarative code, as much as you possibly can. Be a geographer of code, just because I like geography. And yeah, dependency injection, just do it. Great. Thank you very much.